Now let's go to the second question. Use the first derivative to find the stationary points of this function, and classify all the stationary points by the first derivative. So we have the first step. We get the p prime of x equals 3x squared minus 6. Remember, the power rule of a derivative is drop down the exponents, then minus 1 is x to the first power plus 12 times 1. So we get the 3x squared minus 12x plus 12. Now the second step is we will set up the derivative equal to 0. So 3x squared minus 12x plus 12 equal to 0. You can use a graphing calculator to solve to get the 0. Or we can factor this. You will get the x squared minus 4x plus 4 equal to 0. So you get the 3x minus 2 times x minus 2 equal to 0. So the x1 equals 2. Only have one solution to this derivative, the third one. We want to get the y1. That equals, we substitute this 2 for this x, the original function. You will get the 2 to the third power minus 6 times 2 squared plus 12 times 2. So you will get the 8 minus 24 plus 24 equals 8. For this is the one, you can use a graphing calculator, get the answer. Now we already know the stationary point, that is 2, 8. We need to use the first derivative to decide its a local maximum or local minimum or stationary inflection point. So we do the at x equals 2. We will do neighbor value test. This is x. Remember, we use the first derivative. Okay, so you have here's 2. This one is 2 plus 0.1. And here's 2 minus 0.1. After you substitute 2 minus 0.1 and 2 plus 0.1 to this derivative function, you could see this is a positive, here's a 0. When first derivative is a positive, that means increasing. Then increasing again. So you could say that is there's some the graph something like this. It will be the stationary inflection point. So I just label as IP. So at x equals 2, it is a stationary inflection point.